Hi, my name is Ashley Landquist. I'm project lead of blockchain and digital currency at the World Economic Forum. I'm joined in this talk by Dr. Mauricio Tovar of the INTI Colombia Research Group at the National University of Colombia, as well as Dr. Sebastian Benescu, Senior Research and Design Engineer at QuantStamp. In this talk, we will be presenting to you our project work led by the World Economic Forum called Exploring Blockchain Technology for Government Transparency, blockchain-based public procurement to reduce corruption. This project work takes a very multidimensional and comprehensive approach to exploring blockchain for anti-corruption, looking at angles that include public policy and technical and technology angles, as well as civic engagement. From a higher level perspective, what we're doing in this project is investigating whether blockchain can add value in public procurement. What is public procurement? Briefly, this is the process of government contracting or tendering, where governments at the local, regional, or national levels purchase goods, services, and other works, such as building bridges or schools or building airports, to supplying hospitals and schools. Globally, public procurement is about $9.5 trillion of spending. It's actually also the site where more public sector funds are lost to corruption than anywhere else in the world. So this is where the most money is lost to corruption globally. It's about 2 to 3% of GDP, or $1.5 to $3.5 trillion lost, lining the pockets of corrupt officials. Here are some more statistics. About 57% of foreign bribery cases are for obtaining a public procurement contract. And typically, in a given contract, for instance, a city wants to build a bridge, about 10 to 30% of the contract's overall value will be lost to corruption. At the World Economic Forum, we decided to partner with the Inter-American Development Bank, as well as the Office of the Inspector General of Colombia, to really investigate whether blockchain can be applied as the base layer technology to an electronic procurement system, and if that would be helpful. So if we run a procurement system on blockchain technology, can we increase transparency and accountability in this process, and thus move the needle in reducing corruption? That was the purpose of this investigation and project. Here's a higher level overview of the procurement process. The chart on the right shows the 4 phases of procurement: planning, bidding, bid evaluation, and implementation and monitoring. Each of these phases has different areas where corruption tends to seep in and occur. So on the left, we present just a few of these. Of course, we've done extensive research on all of these corruption risks in procurement, speaking with leading international organizations and doing site visits in Colombia. But just as some quick examples, places where corruption can occur in the procurement process include undue influence on needs assessment. That's in the planning phase. This is when the city or other government tenderer decides what it wants to create a contract for and hire vendors to produce. Bid offer tailoring. This is when the tenderer creates a quite catered tender offer that would benefit a specific private sector vendor. Bribery, which can occur between the competing vendors and the tenderer, such as the city. Vendor bid price collusion. This is where different vendors could get together and collude to set a higher price for all of their bids. Conflicts of interest. For instance, a government official such as a mayor or governor may have been elected with the support of some officials from the private sector who are then leading these companies competing for contracts. And then the government representative wants to pay back a favor and award the contract to that company. Fraudulent submissions and bid evaluations. Perhaps the tenderer is misrepresenting its capacities and history and abilities to fulfill a contract, or fraudulent bid evaluations when the city might improperly score certain bids, the competing bids from the vendors, or poor contract benchmarking, which is where you're not receiving adequate and accurate information about what a price should be to deliver a contract, to deliver a good or service, such as the building of the bridge, and inadequate record keeping. So these are issues across public procurement across the world today. In this project, we decided to focus on the bidding and bid evaluation phases of procurement and ask, okay, if we run an e-procurement, electronic procurement system on blockchain technology, can we reduce the corruption risks that happen in those phases? We wanted to identify the overall value of blockchain in this process and also develop groundwork for similar experimentation and innovation worldwide. As a preview, the World Economic Forum just last week on Wednesday, June 17, released a report called Exploring Blockchain Technology for Government Transparency, Blockchain-Based Procurement to Reduce Corruption. So you can find this online, and it's the extensive report from this project. You can find all the details of the project there. It also includes technical design and specification recommendations for a blockchain-based e-procurement system. In other words, other countries around the world might be interested in developing a project such as this for themselves, developing a proof of concept or a pilot using blockchain for e-procurement, and they can see our technical design recommendations and specifications. Of course, technology researchers may also be interested in this. We also perform an analysis of technical limitations for the use of public permissionless blockchain. And as I'll speak to later in this presentation, we also look at permissioned and hybrid blockchain configurations and how they would fare for this use case. We also make numerous policy recommendations on the more institutional and public policy side that would do well to complement a technology intervention such as this in a country. We also discuss civic engagement strategy, how to really get people engaged and involved in this electronic blockchain-based procurement platform. As we'll talk about later in this presentation, a premise of this project is that citizens would actually engage and monitor the procurement process as it's happening live in real time with the data in the back end operating with blockchain technology. However, they could go into a normal website and see the different transactions and decisions happening in the procurement process. And at certain periods of those process, they can leave comments as to potentially suspicious activity. So we recommend engaging and activating citizen monitors from anywhere around the world to watch the procurement process, and they can leave comments. We also have a model or sample RFP for governments. This is basically a blueprint for what a solution like this would look like and how they might want to hire a technical team to build it, and an analysis of additional anti-corruption use cases, such as grant disbursements or land registries and titles that are often discussed in the blockchain ecosystem. And then finally, as an extensive list of related research. So from a higher level, once again, what we're doing here is we've created a software proof of concept to uncover key capabilities and limitations for blockchain for procurement. It's designed for the Ethereum mainnet, and it focuses on the vendor bidding and bid evaluation phases of procurement. We're investigating the benefits of permissionless blockchain for the anti-corruption use case. We also include enumeration of complementary policy goals, policy proposals that would strengthen procurement integrity if implemented alongside a technological e-procurement intervention such as this with a blockchain-based procurement system. We focused on the specific auction of the public school meals program of Colombia. I mentioned before, this is in partnership with the Colombian Inspector General's Office. We identified together with the Inspector General's Office a high-risk contracting activity that exists in the country related to the public school meals program. In Spanish, this is Programa de Alimentación Escolar. And historically, there's been a lot of corruption in the selection and awarding of contracts to fulfill the meals in different cities in Colombia. It was exposed a few years ago that chicken breasts, part of the meals, were marked up 4 times their market price. So in other words, the vendors were getting paid extra to deliver chicken in the meals, and 32 million meals went undelivered in 2016, where the vendors pocketed the money for the costs to produce the meals, but didn't end up producing them. The Colombian Inspector General's office really wanted to investigate, as part of a broader technological research initiative, whether blockchain can help develop their institutional capacity to fight corruption in public procurement. They're generally the institution in Colombia that investigates corruption and other allegations against public sector officials in Colombia. So why did we think blockchain could be a high potential match for public procurement? Certain features of blockchain technology were very interesting to us as we thought about the procurement use case. First, you can have permanent and tamper-evident record keeping. Second, with blockchain, you could have real-time procedural transparency and auditability. So in other words, when certain decisions are made in the bidding and vendor selection phase, we can see in real time those decisions and the records related to them are posted on Ethereum. Documents are also posted on IPFS in our proof of concept. We can also take advantage of smart contracts to encode automated functionalities. For instance, by Colombian law, there is a required minimum bidding period where anyone around the country should be able to submit bids to compete for a tender offer. Smart contracts enforce the minimum period so that a city or a tenderer cannot close that period early. They also enforce minimum periods of the public to leave comments and scrutinize decisions and actions. Those are all embedded in our proof of concept. And when the public leaves comments, because we can take hash records, hashes of those comments and put them on Ethereum, we can prevent against anyone deleting or manipulating the nature of these public comments. So we can truly have uncensored citizen engagement. These are particularly valuable features for anti-corruption contexts, where you could have corrupt officials owning databases or records. Why Ethereum? We get this question sometimes. First of all, of course, we needed a Turing-complete blockchain network because we're taking advantage of smart contracts. Ethereum also has the highest security in terms of network hash rate of all of the Turing-complete public blockchains. And we really also wanted to look at permissionless Ethereum configuration because these maximize security and decentralization in terms of that hash rate, which makes it so when vendors submit bids, people can't delete the record of the bid ever having happened. If we're using Ethereum, they can't delete public comments, and we can take hashes of the bid offers from vendors and comments, as well as the initial tender offer from the city, to check against any of these parties potentially altering those records later. And of course, we needed a public blockchain for visibility and transparency. And lastly, Ethereum has the largest currently ecosystem of technical contributors, researchers, and developers. So for all of these reasons, we were most interested in the Ethereum permissionless blockchain for this experiment and research study. Next, I'm going to turn to colleagues to discuss the key technical challenges of this research project in a little more depth. But first, I want to provide some background information that in public procurement, typically around the world, we have an anonymous or blind auction process. So the people submitting bids for the auction, again, for instance, competing to be the construction firm chosen to build a bridge. Their bids their bidding information and their identities must be anonymous during the bidding period that starts the process. This is so that the different vendors, the different companies can't collude with one another to set higher prices. And it also helps preserve the integrity of the auction process in other ways. So again, this is an anonymous auction process required by law in Colombia and in many countries around the world. And if helpful for additional background information, these are reverse auctions where the lowest price to perform the service wins the contract, because of course the government would like to pay the most competitive, lowest price for the delivery of the good and service. And they also take into account many other aspects of the bid offer from the company, from the vendor, such as their qualifications and experience. Vendors should not be able to change their bids once submitted, of course. They shouldn't be able to, after the bidding period closes, change the information in their bids, because now they might be able to see bid details, which are exposed, again, only after that first anonymous bidding period closes. And bidders and tenderers do not know who placed the bids, as I mentioned. Okay, I will now turn it to my colleague, Sebastian, to discuss a few of the high-level technical requirements as well as challenges that we encountered during this project.
Thank you, Ashley. We actually had a very challenging requirement, which is shown here at the top of the slide, to preserve vendor anonymity on a public permissionless blockchain like Ethereum, but just during the bidding phase, so not forever. And this even made it even more challenging. We managed to do this using hidden ID. Basically, this hidden ID is public-private key pair generated on the vendor's machine, which they only have access to, and they use this to create a cryptographic commitment scheme where inside of this commitment scheme they can encrypt all the details of their bids along with their original and true identity. They encrypt everything inside of a larger ciphertext, and because this ciphertext might be too large to store on Ethereum itself, we actually take a hash of this ciphertext and a reference to it once we store it on IPFS, and then we store the hash and the reference to IPFS on Ethereum itself. After the bidding period ends, the bid evaluation period starts, and then these bids which have been placed can be revealed, and only at that point can the vendor reveal this private key that they generated at the beginning to reveal their identity and their bid. And that's how we managed to overcome this first challenge. For the second challenge, we have the confidentiality of the bid contents during the bidding phase, and it basically contains the same explanation as I had before, where the bid itself, the contents of the bid, are encrypted using this cryptographic commitment scheme, and they are afterwards revealed through the release of this private key that the vendor has generated privately on their machine. And of course, all of this is done seamlessly for the vendors in the software client that we built for them. The third challenge here is protecting against alteration of bids once they have been submitted, because of course we wouldn't want any vendor to be able to change their mind once the evaluation has been finished, for instance. This could be possible if we would use a classical database, and if we had a corrupt administrator, that administrator could, for instance, just change the numbers and be able to show that the vendor actually offered higher prices. But in the case of Ethereum, we actually have strong cryptographic hash functions which are applied on the bid contents itself. And therefore, if any changes are made to these bid contents, even if their changes have been made while it has been, or like for the encrypted ciphertext, we can notice those changes immediately through the collision resistance of these hash functions. Finally, we have the risks of spamming and draining attacks, which of course have been due to one of our design choices, the design choice to let everyone participate in placing bids and adding comments during the bid evaluation and the final implementation and monitoring phase, because we want to let we have this requirement actually to have an uncensored system, right? So we didn't want to place any barriers here, including the barrier of obtaining cryptographic currencies or cryptocurrency, which can be used for placing a comment or a bid on Ethereum. Therefore, we implemented a similar mechanism to the gas station network, where we let the clients that we implemented or a web interface uh, directly communicate with a smart contract which has been preloaded with Ether, and therefore it does not cost the end users, either vendors or commenters, the civic participants, any gas. Of course, spamming is a problem in any kind of system. You basically, if you leave it open, you don't want it to be censored. You have a lot of spamming going on from participants who don't really care about the contents, because they just want to have a lot of activity and basically make the life of the evaluators a bit harder. We have managed to overcome these with classical security measures such as reCAPTCHA. And the draining attacks are something very specific to our solution here. And basically here, we also rely on these kind of mechanism that we used for anti-spamming in order to prevent, for instance, an automated script from simply creating an endless amount of comments and draining the accounts that we have preloaded. And that's the things that I wanted to talk about. Thank you very much.
Next, I will turn it to my colleague, Mauricio.
Thank you, Ashley. Thank you, Sebastian. Another key technical challenge that we had is how the system validates a legitimate bidder uh, despite the anonymity of the vendors and the confidentiality of the bid details that the process needs, as Ashley mentioned. And in the specific case of Colombia, if any company wants to be part of a procurement process, they have to accomplish some requirements of the National Bid Agency. And once they accomplish that requirements, they have a certificate. So that certificate have to be in the bid. And once we unencrypted that information, we can see if they have the certification of the National Bid Agency. So anyone can present a bid, but only the companies that accomplish or that have that certificate are the legitimate ones. Another important thing for the project, and as Sebastian mentioned, is to encourage the civil society and to participate with in different parts of the process during the bidding, in the bid evaluation, and in the vendor selection. And we develop a very easy to use web page that they can make all of the comments in that different stages of the project of the process, I'm sorry. And we don't ask for any ID information in that web page. and that have the problem that Sebastian mentioned about the spamming. But we prioritize that because of the privacy of the citizens. For us, the privacy of the citizens is very important because there is a lot of money in the game in this process, in this procurement process, and if some company lost a business because one person reports a very specific or a probably corruption case, that company can have some retaliation or that person can be in risk. So for the project, the privacy of the citizens is very important to protect them. Thank you, Ashley.
I will now discuss some of the project findings and the overall conclusions from our work. These are also, of course, available in our report. First, we find that public permissionless blockchain provides really unmatched data permanence and censorship resistance. It's very difficult to alter or remove records of tender offers, vendor bid offers, or public comments on suspicious activity once they are submitted. And of course, just to remind, we developed a proof of concept for this project. This feature, data permanence and censorship resistance, is highly valuable for corruption contexts. When you couple this with other DLT capabilities like the automatic smart contract functionalities, the public view, and other features, then the benefits of blockchain become apparent. On the right, here is a chart from the report, just outlining some of the key benefits of public permissionless blockchain, Ethereum, of course, in this case. However, there are also downsides and limitations to blockchain and public permissionless blockchain for this use case. And I think that these are really exemplary of the types of limitations that enterprise and the public sector would find in other use cases. These relate to scalability. For instance, if this were to be deployed at scale, Ethereum wouldn't be currently ready to host hundreds or thousands of procurement auctions around a single country, let alone around the world. And of course, and there are also challenges to maintaining vendor anonymity that we didn't get into very much in this conversation, but I encourage you to look at in our report. And both of these, scalability and anonymity challenges, point to the importance of research and development in cryptography and scalability in blockchain. There are also downsides and limitations to spamming and draining, as we mentioned, and others. Overall, the limitations point to the potential value of permissioned or hybrid blockchains to address scalability and some of the anonymity challenges, and some of the other challenges related to spamming and others. So in this chart, on the left-hand side, we have the issue related to public permissionless Ethereum or blockchain. The next column is green if permissioned blockchain makes it better, yellow if it has a neutral effect, and red if it's worse. And the third column from the left is the case for a hybrid blockchain. And here we're talking about you performing some activities on the permissioned chain, such as the regular bid submissions and decisioning, and taking some hashes and outputs and putting them on Ethereum. No technology solution, of course, overall is able to reduce corruption risk in certain human activities like bribery that can continue to occur. We do want to also finally point out that while we do point to permissioned or hybrid blockchains potentially providing some value here, it's really with that use of Ethereum or a public permissionless chain where you get that strong censorship resistance and the value of recording hashes at least on that blockchain, which is so valuable for anti-corruption contexts. And thank you, that concludes our presentation.